evening. This is my chosen problem, and by the way, I am Genevieve Gail I. Carlos. Currently a third-year student of BSCE or Bachelor of Science in Civil Engineering. So here is my problem. An 8-meter long cantilever T-beam shown supports a uniformly distributed load of 8 kN per meter, including its own weight throughout its length. To prevent excessive deflection of the beam, it is pre-stressed with 16 mm diameter strands, causing a pre-stress force of 650 kN. Find the following. A. Calculate the moment of inertia of section. B. Determine the resulting stress at the top fiber of the beam at the fixed end if the center of the gravity of the strands is 75 mm above the neutral axis of the section. And C. Determine the eccentricity of the pre-stress force at the fixed end such the resulting stress at the top fiber of the beam at the fixed end is 0. First, we need to calculate the moment of inertia, which is mentioned in letter A. Moment of inertia is the quantity that expresses an object's resistance. So, in order to calculate the moment of inertia, we need to divide the T-section or the T-beams into two segments. Here you can see the A1 and the A2, which is the area 1 and the area 2. Other than that, we need to mark the neutral axis in the T-beam. So after dividing the T-beam into two segments, we can now identify the formula of the moment of inertia, or define how to find the moment of inertia. The formula of the moment of inertia is I is equal to I bar plus A times D, or area times D, which is vertical distance from the centroid of the segment. I represents the moment of inertia, I bar represents the inertia of each segment, A represents the total area of a segment, and the vertical distance from the centroid of the segment. So now we can calculate the area first. At area 1, we have 300 times 100, or the base times height. (300 times 100 is equal to 30,000. And for the area 2, we have the 500 times 100, which is 50,000. Other than that, other than the values we also need to get the center of the gravity of the T-beams. Let us say the center of the gravity of the T-beams is the Y-bar. So, in order to get the center of the gravity of the T-beam, or the formula we're gonna need is A sub T times Y-bar is equal to the summation of A times Y sub I. Sorry for the noise. AT, or A sub T, is the total area, which is 80,000, times Y bar is equal to A is the area of the segment, 30,000, times 550. 550 came from the, sorry for the wrong direction of my pen. It is a 100 divided 2 times plus 500. That is where come 550 plus 50,000 times 250, which is 500 divided 250. Now, if we will calculate this equation, we will get Y bar we will get 362.50 or 0.5 millimeter from the bottom fiber. Okay, y bar is the center of the gravity of the TB. Now, the formula for the I bar is 1/12 base times height to the power of 3. Now, we have the formula of the I bar. We can now calculate the moment of inertia. We have the value for the A or the area, and for the vertical distance from the center of the segment. Now, I, or moment of inertia, is equal to 1/12 or 1/12 times base times height, which is the 300 times 100 to the power of 3 plus 30,000, which is the area, and the D, or the vertical distance from the centroid of the segment, which is 100/2 plus 500 minus 362.5 squared. Now, plus another from the segment, or from the A2, or from the area 2, 1/12 times 100 times 500 to the third power plus 50,000 times 362.5 minus 250 squared. Now, if we will calculate this, we will get 27.541 times 10 to the 8th power millimeter to the 4th power. Now, we have the moment of inertia. Let's proceed to letter B.